Good day, everybody. Today we'll continue with the solutions to exercise 1.3. We'll proceed with the solution to problem 1b. Problem 1b. Given alpha and beta are the roots of 2x squared plus 3x minus 4 equals 0. Clearly, a equals 2, b equals 3, and c equals minus 4. We recall that alpha plus beta equals minus b over a, and alpha beta equals c over a, which implies alpha plus beta will be equal to minus 3 over 2, and alpha beta will be equals to minus 4 over, will be equal to minus 4 over 2. Minus 4 over 2, which is equal to minus 2. Now we know that alpha prime equals 2 alpha and beta prime equals 2 beta. Something which results in alpha prime plus beta prime equals 2 alpha plus 2 beta, which is equal to 2 into alpha plus beta, which is equal to 2 into minus 3 over 2, which is equal to minus 3. And alpha prime beta prime is equal to 2 alpha times 2 beta, which is equal to 4 alpha beta. This will be equal to 4 into minus 2, which is equal to minus 8. Now, just hold 1 second, please. Let me wrap up this portion of the board. Give me 1 second, please. Our new equation is given by x squared minus into alpha prime plus beta prime all into x plus alpha prime beta prime equals 0. Substituting for alpha prime plus beta prime and alpha prime beta prime above, we have x squared minus into minus 3 x minus 8 equals 0. a thing which results in x squared plus 3x minus 8 equals 0. And this is our new equation. So I'll let you guys take down notes. But in the meantime, let me go further to explain it. We are given alpha and beta are the roots of 2x squared plus 3x minus 4 equals 0. Clearly, a equals 2, b equals 3, and c equals minus 4. Recall, alpha plus beta equals minus b over a, and alpha beta equals c over a, which implies alpha plus beta equals minus 3 over 2, and alpha beta equals minus 4 over 2. Now alpha prime equals 2 alpha, beta prime equals 2 beta. This implies alpha prime plus beta prime equals 2 alpha plus 2 beta, which is equal to 2 into alpha plus beta, which is equal to 2 into minus 3 over 2, the thing which results in minus 3. Alpha prime beta prime equals 2 alpha times 2 beta, which is equal to 4 alpha beta. This gives us 4 into minus 2, which is equal to minus 8. Our new equation is given by x squared minus alpha prime plus beta prime x plus alpha prime beta prime equals 0. Substituting for alpha prime plus beta prime and alpha prime beta prime above, we have x squared minus into minus 3x minus 8 equals 0, a thing which results in x squared plus 3x minus 8 equals 0. And that's our new equation. So take 1 minute to copy that. Now let's do example 1C. Example 1C. Given nine x squared plus 24x plus 16 equals 0. Clearly, a equals 9, b equals 24, and c equals 16. We recall here that alpha plus beta equals minus b over a, and alpha beta equals c over a, which implies in this case that alpha plus beta equals minus 24 over 9, which is equal to minus 8 over 3, minus 8 over 3, and alpha beta equals 16 over 9. Now we know that alpha prime equals 2 alpha and beta prime equals 2 beta. The thing which results in alpha prime plus beta prime equals 2 alpha plus 2 beta, which is equal to 2 into alpha plus beta, which is equal to 2 into minus 8 over 3 equals minus 16 over 3. And alpha prime beta prime and alpha prime beta prime equals 2 alpha times 2 beta, which is equal to 4 alpha beta, which is equal to 4 into 16 over 9. That gives us 64 over 9. Now, our new equation is given by x squared minus alpha prime plus beta prime x plus alpha prime beta prime equals 0. So if we substitute for alpha prime beta prime, alpha prime plus beta prime, and alpha prime beta prime above, we have x squared minus into minus 16 over 3 plus 64 over 9 which upon further simplification gives us 9x squared plus 48x plus 64 equals 0, and this is our new equation. (48x) please. So we see here that given alpha and beta are the roots of 9x squared plus 24x plus 16 equals 0. Clearly, A equals 9, B equals 24, and C equals 16. Recall, alpha plus beta equals minus B over A, and alpha beta equals C over A, which implies alpha plus beta equals minus 24 over 9, which is equal to minus 8 over 3, and alpha beta equals 16 over 9. Now, alpha prime equals 2 alpha and beta prime equals 2 beta, which implies alpha prime plus beta prime equals 2 alpha plus 2 beta, which is equal to 2 into alpha plus beta, which is equal to 2 into minus 8 over 3 equals minus 16 over 3. Alpha prime beta prime equals 2 alpha times 2 beta, which is equal to 4 alpha beta, which is equal to 4 into 16 over 9, which is equal to 64 over 9. Our new equation is given by x squared minus into alpha prime plus beta prime bracket into x plus alpha prime beta prime equals 0. Substituting for alpha prime plus beta prime and alpha prime beta prime above, we have x squared minus into minus 16 over 3 x plus 64 over 9 equals 0. So if we further simplify, we'll have 9x squared plus 48x plus 64 equals 0. And our solution is complete. So I'll give you time to take down some notes. Now let's go on to exercise 1D, example 1D or exercise 1D, whatever you call it. Given alpha and beta are the roots of 3x squared minus x minus 6 equals 0. Clearly, A equals 3 here. B equals minus 1. and C equals minus 6. Recall, alpha plus beta equals minus B over A and alpha beta equals C over A. So in this case, alpha plus beta will be equal to minus 1 over 3 and alpha beta will be equal to minus 6 over 3, which is equal to minus 2. Now we know that alpha prime equals 2 alpha and beta prime equals 2 beta. Continuing this way, we see that alpha prime plus beta prime equals 2 alpha plus 2 beta, which is equal to 2 into alpha plus beta. And our alpha plus beta in this case is minus 1 over 3. This results in minus 2 over 3. Now alpha prime beta prime equals 2 alpha times 2 beta, which is equal to 4 alpha beta. In this case now, alpha prime beta prime will be equal to 4 into minus 2, which is equal to minus 8. So our new equation is given by x squared minus alpha prime plus beta prime x plus alpha prime beta prime equals 0. Substituting for alpha prime plus beta prime and alpha prime beta prime above, we have x squared minus into minus 2 over 3 x minus 8 equals 0. A thing which upon simplifying yields 3x squared plus 2x minus 24 equals 0. And that is our new equation. So let me explain further. Exercise 1D. Problem 1D. Solution to problem 1D of exercise 1.3. Given alpha and beta are the roots of 3x squared minus x minus 6 equals 0. Clearly, alpha equals 3, beta equals minus 1, and clearly A equals 3, beta equals, B equals minus 1, and C equals minus 6. Recall, alpha plus beta equals minus B over A, and alpha beta equals C over A. This implies alpha plus beta equals minus 1 over 3 and alpha beta equals minus 6 over 3, which is equal to minus 2. Now, alpha prime equals 2 alpha and beta prime equals 2 beta. This implies alpha prime plus beta prime equals 2 alpha plus 2 beta, which is equal to 2 into alpha plus beta, which is equal to 2 into minus 1 over 3, the thing which yields minus 2 over 3. Alpha prime beta prime equals 2 alpha times 2 beta, which is equal to 4 alpha beta, which is equal to 4 into minus 2. That gives us minus 8. Our new equation is given by x squared minus into alpha prime plus beta prime bracket x plus alpha prime plus beta prime equals 0. Substituting for alpha prime plus beta prime and alpha prime beta prime above, we have x squared minus into minus 2 over 3 x minus 8 equals 0. And if we further simplify, this gives us 3x squared plus 2x minus 24 equals 0 as our new equation. Let me give you some time to come. Now let's move on to problem 2. Solution to problem 2. Problem 2 reads, if alpha and beta are the roots of the equation, problem 2, alpha and beta are the roots of 3x squared minus x minus 5 equals 0. Find without solving the equation. So from this we see clearly that A equals 3, clearly A equals 3, B equals minus 1, and C equals minus 5. Alpha plus beta equals minus b over a, and alpha beta equals c over a. Solution to problem 2 continues. Now problem 2a states find without solving the equation 1 over alpha plus 1 over beta. We see here that this is a fraction, and this fraction yields has as an LCM alpha beta. So this yields beta plus alpha here, which is equivalent to alpha plus beta all over alpha beta. And we know clearly here that alpha plus beta is equal to minus b over a. So this will give us minus b over a all over alpha beta, which is equal to c over a. C over a, which gives us minus b all over c. This is equal to, we know what b is. We know what b is and what c is. We know that b is equal to minus 1. So this will be minus into minus 1 all over minus 5. This gives us minus 1 all over 5. Minus 1 all over 5. And that is our solution. Question B reads, alpha plus beta we know is equal to minus b over a, which is equal to minus into minus 1 all over 3, which is equal to 1 over 3. C, alpha beta equals c over a, which is equal to minus 5 over 3, which is equal to minus into 1 and 1/3. D, alpha squared plus beta squared is equal to alpha plus beta all squared minus 2 alpha beta. This is equal to we know alpha plus beta is equal to 1 over 3. So that will be 1 over 3 all squared minus 2 into minus 5 over 3. This gives us one over 9 plus 10 over 3, which upon simplifying further will give us 31 over 9. We could leave that at that. 9 is common here, so 9 goes into 3 is 3, and that gives us that. And E, 3 alpha plus 3 beta is equal to 3 into alpha plus beta. Let's erase this, it's too close to E, 3 alpha plus 3 beta equals 3 into alpha plus beta, which is equal to 3 times 1 over 3, which is equal to 1. And that's the solution to Problem 2 of exercise 1.3. Given alpha and beta are the roots of 3x squared minus x minus 5 equals 0. Clearly, a equals 3, b equals minus 1, and c equals minus 5. Alpha plus beta, we recall, is equal to minus b over a. And alpha beta equals c over a. Question 2a. Find 1 over a plus 1 over b. You see, when we this a fraction with LCM alpha beta. So this results in alpha plus beta over beta alpha beta, which is equal to minus b over a all over c over a, which is equal to minus b over c. And this yields minus 1 over 5. Question 2b required us to look for alpha plus beta, which is equal to minus b over a, which is equal to minus into minus 1 over 3, which is 1 over 3. 2c required us to look for alpha beta, which is equal to c over a, which is equal to minus 5 over 3. A thing which yields minus 1 and 1/3. Now, d, as alpha squared plus beta squared equals alpha plus beta all squared minus 2 alpha beta. A thing which yields 1 over 3 all squared minus 2 into minus 5 over 3. That gives us 31 over 9. E, 3 alpha plus 3 beta equals 3 into alpha plus beta, which is equal to 3 times 1/3, which is equal to 1. And our solution is complete. Let me give you time to jot down the steps. Now let's do problem 3 of exercise 1.3, 1.5, I mean, of exercise 1.3, I'm sorry. Problem 3. Given alpha and beta are the roots of 2x squared minus 5x minus 4 equals 0. Find the equations whose roots are A. First, we know clearly that A equals 2, B equals minus 5, and C equals minus 4. Recall alpha plus beta equals minus b over a, and alpha beta equals c over a. This implies in this case that alpha plus beta equals minus 5 over 2 and alpha beta equals minus 4 over 2, which is equal to minus 2. So our solution continues this way. Solution to problem 3 continues. Problem 3a requires that we solve for, we find the equation whose roots are 1 over alpha and 1 over beta. A, alpha prime equals 1 over alpha and beta prime equals 1 over beta. This implies alpha prime plus beta prime alpha prime plus beta prime equals 1 over alpha plus 1 over beta, which is equal to alpha plus beta all over alpha beta. We know here that alpha plus beta is equal to minus 5 over 2. This gives you minus 5 over 2, and alpha beta equals minus 2 all over minus 2. A thing which results in 5 over 4. Now alpha prime beta prime equals 1 over alpha times 1 over beta is equal to 1 over alpha beta. We know that alpha beta is equal to minus 2. So this yields minus 1 over 2. Our new equation is given by x squared minus into alpha prime plus beta prime x plus alpha prime beta prime equals 0. Substituting for alpha prime beta prime above, substitute for alpha prime plus beta prime and alpha prime beta prime above, we have x squared minus into five over 4x minus 1 over 2 equals 0. Upon further simplification or simplifying, we have four x squared minus 5x minus 2 equals 0. And that is our new equation. So given alpha and beta are the roots of 2x squared minus 5x minus 4 equals 0. Clearly, a equals 2, b equals minus 5, and c equals minus 4. Recall, alpha plus beta equals minus b over a, and alpha beta equals c over a. This implies alpha plus beta equals minus 5 over 2, and alpha beta equals minus 4 over 2, which is equal to minus 2. A. Given alpha prime equals 1 over alpha and beta prime equals 1 over beta, this implies alpha prime plus beta prime equals 1 over alpha plus 1 over beta, which is equal to alpha plus beta all over alpha beta. That is equal to minus 5 over 2 all over minus 2. That gives us 5 over 4. Alpha prime plus beta, alpha prime beta prime equals 1 over alpha times 1 over beta, which is equal to 1 over alpha beta. That is equal to minus 1 over 2. Our new equation is given by x squared minus into alpha prime plus beta prime x plus alpha prime beta prime equals 0. Substituting for alpha prime plus beta prime and alpha prime beta prime above, we have x squared minus into 5 over 4x minus 1/2 equals 0, which when simplified gives us 4x squared minus 5x minus 2 equals 0. And that solution is complete. So now we'll do example B. Take down the notes. We'll do problem 2B. Problem 2B. Alpha prime equals alpha over beta, and beta prime equals beta over alpha. Clearly, alpha prime plus beta prime will be equal to alpha over beta plus beta over alpha, which is a fraction alpha over alpha beta. So solving this fraction, we see that this will be alpha squared here plus beta squared all over alpha beta, which is equal to alpha plus beta all squared minus 2 alpha beta all over alpha beta. So if we substitute our figures for alpha plus beta and alpha beta, we have minus 5 all over 2 all squared minus 2 into minus 2 all over minus 2. This implies alpha prime plus beta prime equals we'll erase this so we'll have a space to write clearly so you guys don't get jumbled up. So this implies alpha prime plus beta prime equals minus 5 squared is 25, 25 over 4 plus 4 all over minus 2. This gives us 25 plus 16. 25 plus 16 all over minus 4. This is equal to minus 41 over 4. Alpha prime beta prime equals alpha over beta dot beta over alpha, which clearly equals 1. Now, our new equation is given by is x squared minus into alpha prime plus beta prime all into x plus alpha prime beta prime equals 0. So if we substitute for alpha prime plus beta prime and alpha prime beta prime above, we have x squared minus into minus 41 over 4 x plus 1 equals 0. This yields 4x squared plus 41x plus 4 equals 0, and that is our solution to problem B. We know clearly from here that A equals 2, B equals minus 5, and C equals minus 4. We recall that alpha plus beta equals minus B over A, and alpha beta equals C over A, which implies alpha plus beta equals minus 5 over 2, and alpha beta equals minus 4 over 2, which is equal to minus 2. Given alpha prime equals alpha over beta and beta prime equals beta over alpha, this implies alpha prime plus beta prime equals alpha over beta plus beta over alpha, which is equivalent to alpha squared plus beta squared all over alpha beta. which is equal to alpha plus beta all squared minus 2 alpha beta over 2 alpha beta. Substituting these figures into this relationship gives you alpha prime beta prime equals all of this, which gives us minus 41 over 4. Now, product of roots. Alpha prime beta prime equals alpha over beta times beta over alpha, which is equal to 1. Our new equation is given by x squared minus alpha prime beta prime all into x plus alpha prime beta prime equals 0. Substituting for alpha prime plus beta prime and alpha prime beta prime above, we have x squared minus into 41 over 4 x plus 1 equals 0, which on simplifying gives us 4x squared plus 41x plus 4 equals 0. So break down notes. Now let's go to problem 2C. Let's go to problem 3C, sorry. 3C, not 2C. Problem 3C. Alpha prime equals alpha plus beta all squared and beta prime equals alpha minus beta all square. In this case, alpha prime plus beta prime will be equal to alpha plus beta all squared plus into alpha minus beta all squared, which is equal to alpha plus beta all squared plus alpha plus beta all squared minus 4 alpha beta. This is equal to 2 into alpha plus beta all squared minus 4 alpha beta. If we substitute in figures, that gives us 2 into minus 5 over 2 all squared minus 4 into minus 2. This implies alpha prime plus beta prime equals 2 into 25 over 4 plus 8, which is equal to 25 over 2 plus 8, which is equal to 41 over 2. Alpha prime beta prime equals alpha plus beta all squared into alpha minus beta all squared. This is the same thing as alpha plus beta all squared into alpha plus beta all squared minus for alpha beta. So if we substitute our figures in here, this will give us alpha prime beta prime equals minus 5 over 2 all squared into minus 5 over 2 all squared minus 4 into minus 2, which is equal to 25 over 4 into 25 over 4 into 25 over 4 plus 8 which implies alpha prime beta prime equals 25 over 4 times 57 over 4, which is equal to 1425 over 16. So jot that step down before I erase the top. Now our new equation is given by x squared minus into alpha prime plus beta prime x plus alpha prime beta prime equals 0. if we substitute for alpha prime, beta prime, and alpha prime plus beta prime in the above relation, we have x squared minus 8 alpha prime plus beta prime is 41 over 2. 41 over 2 into x plus alpha prime beta prime is 1425 over 16 equals 0. Upon simplification, or further simplification, we have 16x squared minus 8 goes here, 328x plus 1425 equals 0, and that is our new equation. So this is our new equation, and this is the solution to exercise 3C. We know that alpha prime plus beta prime is equal to 41 over 2. If you see the steps in your notes, you will realize that an alpha prime beta prime equals alpha plus beta all squared into alpha minus beta all squared, which is equal to alpha plus beta all squared into alpha plus beta all squared minus 4 alpha beta. Take note, alpha minus beta all squared is equal to alpha plus beta all squared minus 4 alpha beta. So if we slot in figures, we see alpha prime beta prime equals to 1425 all over 16. Now if we substitute these figures into the above equation, we'll have x squared minus 41 over 2x plus 1425 over 16 equals 0. If we simplify, this gives us 16x squared minus 328x plus 1425 equals 0. And that's our new equation. So jot that down.